Today's story is one of a dedicated stylist with a high-strung clientele. It's the story of xanthine oxidase, an enzyme which, among many other things, oxidizes xanthine. Xanthine is the penultimate product of our catabolism of purines. To prevent xanthine buildup in our bodies, we must convert it into another form, which can be excreted. On this particular day, on a metaphorical street that represents your very own bloodstream, everything was going just fine. Doc, you gotta help me. Calm down, sir. What's going on? Look outside, man. Everybody out there looks just like me. There's good reason for xanthine to be nervous. Overabundance of xanthine in the body can be toxic, in severe cases even leading to kidney stones. That's way too many xanthines, man. I gotta be myself. You gotta give me a new, unique look. All right, settle down. I can help you with that. Just take a seat in my active site. While xanthine oxidase gets working on xanthine's brand new look, we can take an in-depth look at the mechanisms involved. Xanthine oxidase's active site is essential to the makeover process. It facilitates the chemical reactions that xanthine oxidase causes and holds xanthine in place while doing so. The active site is called a molybdenum cofactor, or MoCo for short. This region here is the actual catalytic bit, while the rest of this molecule is what we call a pterin. Xanthine oxidase has two active sites, so it can give out two makeovers at a time. Xanthine oxidase has a couple other important tools too. It possesses amino acid residues that are essential for carrying out the oxidation reaction. These residues are glutamate 1261, glutamate 802, and arginine 880. The first step of the reaction is catalyzed by glutamate 802 and glutamate 1261. Though the mechanism is not completely understood yet, we know that glutamate 802 stabilizes a negative charge which holds the substrate in place for the rest of the reaction. After this happens, glutamate 1261 takes over. By abstracting the proton on MoCo's hydroxyl group, the active site's oxygen atom can make a nucleophilic attack on this carbon, on the xanthine. The negative charge is stabilized as seen here, resulting in the formation of this enzyme substrate complex. From here, the second step can begin. In the second step of the reaction, a hydrogen is transferred from xanthine to MoCo's thiocarbonyl group. This breaks the double bond between molybdenum and sulfur, which causes molybdenum's oxidation state to change from 6 to 4. This change causes molybdenum to lose its bond to the oxygen we've attached to xanthine. The end result is that xanthine has been oxidized, but we still need to deal with this negative charge if we want a stable product. In the final step of the reaction, the negatively charged oxygen reforms its pi bond with xanthine. To accommodate this, the neighboring pi bond moves over by one carbon. The next pi bond over ends up binding its nitrogen atom to a hydrogen, which is borrowed from water. While taking a hydrogen from water results in a reactive oxygen species, the water in our reaction is usually able to grab a spare proton from arginine 880. Now everyone's happy, and we're left with a stable final product called uric acid. By transforming xanthine into uric acid, all we've essentially done is added a double bonded oxygen where there wasn't one before, which is a process that's almost a little bit like putting on a hat. Oh my God, I'm beautiful. A new look like this deserves a brand new name. From now on, you can call me uric acid. Uric acid is a pretty useful compound. It acts as an antioxidant, getting rid of reactive oxidative substances, which is good especially considering that xanthine oxidase reactions can form those substances when the water is unable to grab a spare proton. As well, uric acid is a compound that's able to be filtered out of our blood by our kidneys and excreted in our urine, which completes the process of purine catabolism. And so, everything was cool. Until... What is this? Just a few days ago, I was the only uric acid on the street and everybody else was a xanthine. Now everybody's the same as me again. Sorry, sir. But our services aren't exclusive. We pride ourselves on being a productive enzyme, and productive's what you got. I can't be seen looking like everybody else. You need to give me another makeover, a unique one. Sorry, sir, but there's nothing I can do for you. Literally. In a chemical sense, there's no reaction that I can further carry out on you. Unfortunately, xanthine oxidase was unable to do anything further to help out uric acid. And even more unfortunately, a buildup of uric acid in the body can be toxic, causing gout. Join us next week when we talk about allopurinol, a competitive inhibitor of xanthine oxidase that prevents the buildup of uric acid, preventing gout.